Hello students, welcome to the class. Today we will see the theory part 4 of the NCERT chapter 3, classification of elements and periodicity in properties, in which we will cover the section 3.6. So this is the disclaimer. In our today's class, our objective would be to classify the elements into S, P, D, F blocks and try to learn the main characteristics of these blocks. So our today's objective would be to attend the lecture. After attending the lecture, you would be able to classify the elements into S, P, D and F blocks, and also you will be able to learn their characteristics. If I talk about the subpoints under this section 3.6 of the NCERT, the first would be S block elements, which is 3.6.1, P block elements, D block elements, F block elements. Lastly, we will see the last section, which includes the metals, non-metals and metalloids. Then we will deal with some problems related to these subtopics and summarize it with a summary. If I try to classify the whole periodic table on the basis of electronic configuration, then it can be classified into 4 blocks: S block, P block, D block and F block. So this can be seen in the periodic table also. If you look at the periodic table, at the left column, you must be seeing S block written, right? Which includes the group 1 and group 2. Then in the middle part, we have the D block, and on the rightmost part, we have the P block. At the bottom of the periodic table, you will be able to locate the F block elements, which includes the lanthanoids and the actinoids. The most important part regarding this blocks is their outer electronic configuration. So for every S block element, the outer electronic configuration is ns1 to 2. Then for P block element, it is a full filled s orbital, or you would say s subshell, and in that same energy shell we have the p subshell, in which the electrons are filled from 1 to 6. After that we have a D block element, but here the D subshell belongs to a lower energy level, which is n-1. So suppose the S subshell belongs to the 4th energy level, then the D subshell will belong to the 3rd energy level. Example 3D1 4s2. Then lastly we have the F block elements. There is a very tricky part in this configuration. The tricky part is that the D subshell is only filled with 0 electrons or 1 electron. 2 parts. Okay. So either it is 0 or either it is 1. So this thing is seen for the F block elements. The S block element, the S subshell is always filled. The F subshell is partially filled, or sometimes it is 0 also. So again, if I try to look at all of this, then first is NS, second is NS2, NP 1 to 6. D we have n-1D. Okay, n-1D 1 to 10, NS 0 to 2. So S can be 0 or it can be maximum of 2 also. But D should be filled with at least 1 electron. Now in the case of F block element, there may be a chance that there are no electrons in the F block, and the D electrons will not exceed 1 the value of 1. Whereas your S subshell will be completely filled. So this is important to remember. This can be shown in this pictorial representation. On the left hand side we have the S block, the NS1 to 2. In the right hand side, rightmost side, we have NS2, NP1 to 6. In the middle part, we have N-1, D1 to 10, NS0 to 2. And in the bottom panel, we have N-2, F0 to 14, N-1, D0 to 1, and NS2. Yes, it is clear to all of you. Now there is a exception to this characterization, which is very important to address. So that exception is related to two elements. The first one is helium. So your helium must belong to the S block. Okay. What is the reason behind it? Because its outermost electronic configuration is NS2, which is 1s2. It has no electrons in any other subshell also. It is only present in the S. Okay. So it should fall in the S block. But if you remember, what is a helium gas? It is a noble gas. Okay, it is a noble gas. It also exhibits the property of the noble gas because of its complete octet. So it is not belonging to the S block in the periodic table. Instead of that, it belongs to the P block. So that is the most important exception to your general idea of the categorization in blocks. I guess this part is clear to you. Now coming on to the second element, whose position is still, I would say, conflictable. So that is hydrogen. What is the difficulty with this element? So it has both the properties of group 1 and group 17. Your group 1, we know it. It is your alkali metal, sodium, then your potassium and your rubidium. So it has the property of those alkali metal. In addition to that, it has the property of group 17 halogens also. Both are possible. How? If I talk about the alkali metals, you know it, that if your outermost subshell is having 1 electron and that subshell is S, then your element must belong to the alkali metal group or the group 1. So in that sense, hydrogen should belong to the group 1. But you know it very well that hydrogen can take up 1 electron and complete its configuration. Now, this part is also applicable to the halogens. You take the case of fluorine, it accepts 1 electron and goes to the noble gas configuration. Same thing is true for chlorine, for bromine and for iodine. And that same thing is true for hydrogen. Now, due to this reason, its position is still not fixed in the long form of the modern periodic table. Now, this can be well visualized in your upcoming picture. So this is the picture. You can see that there is a green box where H is written in the middle, just above the D block. That is representing a hydrogen. So, to keep it distinct from whole of the periodic table, it is placed there. Therefore, its position is not fixed. But according to the atomic, you would say the periodic law, it should belong to the first position before the helium, above lithium. So that is a theoretical perception. But due to its periodic outcomes, it is not capable of being put there. So I guess this point is clear to you. So this is the theoretical part is saying that your hydrogen should go to the S block. Its properties are saying that it should go to the halogens, and due to this conflict, it is not placed in any of the block. Rather than that, it is placed on the top of all of this block. But on writing the atomic number, that is the theoretical way, you have to write hydrogen before helium. I guess this is clear to you. The two exceptions are quite clear to you. Then now we will try to study each and every block one by one. So if you do this part, this electronic configuration part, in the previous class I have taught about that, and this S block part, then you will be able to get a hold of whole of this chapter, because whole chapter revolves around these two concepts. First is electronic configuration, and second is its position, in which block you are positioning your given element. Okay, so let us talk about the general properties of the S block element. With this, I would give you a reminder that if you are not aware about the modern periodic table, or you are not able to learn it, then just use mnemonics for it. So it is very important to learn the periodic table, and very important to know the positions of each and every element. Okay, without that you will face a lot of difficulty in studying this chapter. So you don't need to remember all of the 118 elements, right? So at least you should know up to the 4th period, and I would say it would be good if you know up to the 5th period. You can ignore the 6th and 7th period, that's good, no problem in that, but you should remember the lanthanoid and the actinoid. So that is a necessity. If I move to the S block element, there are two groups inside it. So alkali metal and alkaline earth metal. We have already discussed some part of it. So alkali metals have a outer shell configuration of NS1, whereas the alkaline earth metals have an outer shell electronic configuration of NS2. Then, due to its high reactivity, it is seen in the combined form. So whenever you obtain an ore of this, suppose you are trying to extract the S block element, any S block element, sodium, lithium, from the Earth's surface, then the chance is that you will obtain these elements in a combined state. What is the meaning of combined state? Means it will be present in the form of salts like your oxides, or it can be a chloride, or it can be a sulfide. So that is mandatory for the S block elements if you find it naturally. Okay, so you will ask, then what are the elements that are found in the free state without any combination with any other elements? You can take a very good example of gold. It is very less reactive, although it belongs to the D block. I am discussing it here to make you aware about the difference between this combined state and the free state. So the gold may contain impurities in the form of dirt and all, but it will not be present in the form of oxides or sulfides. It will be present purely as your gold, which is Au. But in the case of this S block elements or any other reactive metal, you will find them in the combined state, combined with other non-metals. Then the third point. So this is the most important point around this categorization, is that if you move from top to bottom, down the group I would say, then the metallic character increases. If we go with that trend, then lithium will be the least metallic one and cesium will be the most metallic one. The same thing can be said for the alkaline earth metals also. So beryllium, then magnesium, then strontium and barium. Now the problem is that your lithium and beryllium are metals. There is no doubt in it. They both are metals. But their compounds are covalent. So you would notice that lithium and beryllium are the only elements in these two elements. So lithium falls in the alkali earth metal. You have seen it. So it forms covalent compound. Similarly, your beryllium also forms covalent compound. Apart from these two elements, all the S block element form ionic compound. So this is a very important point to remember. Okay. Now let us talk about the general properties of the S block elements. So these are some short points. I will go through them one by one quickly. So they both are soft to touch. Second, they have a low boiling and melting point. They are excellent conductors of heat and electricity because they are metals. So that is a obvious attribute to them. The fourth one, that they show distinctive color when placed in flame. So this is a important point regarded to your practical chemistry. So when we will study the practical part, practical chemistry, where we try to categorize the elements, whether it is sodium or potassium and all, the flame test is a very useful technique to identify them, because each of these elements show a very distinctive, means different color upon heating. So which color it shows, so we'll not study it in this part, we'll study it in the practical chemistry. But this is important point to remember, that they show distinctive color upon burning. The most important point, they are strong reducing agent. Now you won't have an idea of what is reducing agent and all. So I'm giving a very short overview here. So those elements which are capable, or those species which are capable of donating electron, are called as strong reducing agent, because if it is giving electron to someone else, then that substance will get reduced. So this is the proper definition of reduction, that if an element accepts an electron, it gets reduced. So if this S block element is giving electron to someone else, it is helping them to reduce. So therefore they are acting as an agent of reducing, that is strong reducing agent. And since they are metals, they are able to do it in a more easier way. I guess this point is clear to you. Now upon losing of the electron, they form positive ions, right? Now moving on to the next block, which is P block elements. So just try to make notes out of it. So there are small points. Make the electronic configuration in a different part, keep the properties in a different part, and lastly the metals, metalloids and the non-metals. So these are the three parts of today's lecture. We have already told about it. So what are the general properties of P block elements? So your P block element starts from group 13 and moves on to 18, right? Now in between these, some of the parts are removed. So we'll talk about them. What are those parts? So 13 to 18, right? So remember this thing. 1 and 2 belongs to S block. 13 and 18 belongs to the P block. And your S block and P block in together are called as representative element or main group element. So you have seen this term multiple times, main group. So why are we saying it main group? Because whenever you see the S block, you study S block element and P block element in singularity, you call them as main group element or representative element. So this is a very important point. Why I'm telling it as an important point? So it may be not asked in the exam directly, but whenever you read a textbook and they use this kind of terminologies like a representative element and main group element, it becomes difficult for you to read out that textbook. So if you know these terms, it will be easier for you. Now, if I try to categorize each and every element of this period of this P block, then you know that at the end of the any period in the P block comes your noble gas. So you know that every period is characterized by a noble gas. So every P block period ends with a noble gas that has a closed shell valence configuration given as Ns2Np6. So that totals to 8 electrons. Now before that, so since your noble gas is at the last, it is in the group 18. So before that we have group 17 and group 16. So group 17 includes halogens, fluorine, chlorine, bromine and iodine. Now what are chalcogens which are placed in the group 16? So they are just before the group 17. What are chalcogens? What are the name of the chalcogens? So they are sulfur, oxygen. Okay. So just before your fluorine, chlorine and all. Right. So you can refer to the periodic table for this. That which are the elements that belong to the group 16. Yes, very good. So oxygen, sulfur, selenium, tellurium and polonium. Okay. So these are the elements that belongs to the chalcogens. So this is a name given to them. Now behind this, there is some theory. So I would not go into that. So you must just remember that the group 16 are chalcogens and group 17 are halogens. Now we will see some general characteristics of the p block element that are left. Similar to the previous trend, if we move from left to right across a period, so remember these 2 points regarding periods and groups. So first is regarding period. If you are moving from left to right, your metallic character will increase. Okay. So metal is a metalloid which is having both the characteristics of metals and non-metals. So this is a mediate one. Then after then we have carbon, nitrogen, oxygen and fluorine. So as we are moving from boron to fluorine, the non-metallic character is increasing. And neon is the most non-metallic one. So remember this very important point, that non-metallic character increases on moving left to right across a period. This is true for the whole periodic table, not only for the p block elements. Similarly, if you move down the group, we have seen it for the s block also, that the metallic character increases. Why we have not talked about the non-metallic character in case of the s block? Because all of the elements are metals. Therefore, we have not mentioned this first point of non-metallic character. But for this p block, we have both of the points. That from left to right, the metallic character decreases in a period, and for metallic character increases on moving top to bottom in a group. So nitrogen is the most non-metallic one, where bismuth is a metal, right? So you can see that how the transition is happening. First we have two non-metals, then we come in between these metals and non-metals, which is metalloid. Then we slowly move on to the metal, which is bismuth. I hope this part is clear to you. So remember this two important point. This can be applicable to any block. Now let us talk about some general properties of the D block elements. What are the remaining groups in the between? So 1, 2 is your S block, 13 to 18 is your P block, and 3 to 12 is your D block. Now, a very important definition is given here, which is regarding the transition element. So listen it very, very carefully. So questions are asked from here in both competitive exam and the board exams. What are transition elements? Two parts are important here. First, it should have an incomplete D subshell. So this is the first part. The second part is that this incomplete D subshell can be considered in the neutral and ionic form both. So suppose if any metal is there, it has a complete D subshell, but in one of its ionic state, it is having a incomplete D subshell, then also it will be called a transition elements. Okay, so this is important point. Then moving on to the next general property of D block element, it forms colored ions. Then they exhibit variable valency, that is oxidation states. They are paramagnetic in nature, means they are attracted towards the magnet. And also they are used as catalyst. Now we will focus on to this point, what is meant by incomplete d subshell in their neutral or ionic form. Let us try to understand this point with the help of an example. Suppose you consider zinc, cadmium and mercury, 3 elements. Okay. Now they have an outer configuration of n-1 d10 ns2. So this is for the neutral form. No electrons are removed. So they are the only elements present in the D block, these 3, that do not belong to the transition element. So this is very, very important, that zinc, cadmium and mercury are the only D block element that do not belongs to the transition element. The reason behind it is that they have a complete D subshell in their neutral form, which is D10, you can see it, and in their ionic form also. So their ionic form is 2+. If you remove 2 electrons, you will get again D10. So again you have a complete D subshell. As a result, it is not in the transition element. I guess this point is clear to you. It's very important to remember this. Now, why these transition metals or transition elements are called so? Because you can see them as a part which is helping us to transition, or you can say move. So I would say a simple name, I would say a synonym for the transition would be passing through. Okay, to pass through. So when you move from the S block to the P block, it is a passage. So that is the reason we call them as the transition elements or transition metals. So this is a basic idea why we are giving it the name transition element. I guess this part is clear to you. Yes, the Zn2+ will have a configuration of argon 3d10. So whole configuration of argon plus 3d10. Then we will move to the last block, which is F block elements. The first important point is that all the F block elements are metals. Most important point. Second, all the elements within a series. So if you are considering the lanthanoids, then all the lanthanoids are having similar properties. Similarly, all the actinoids have similar properties. Now, why are this F block element placed in the bottom? We have already talked about it. Because in these elements, the F subshell is filled. Due to this reason, they are placed in the F block in a separate panel, or else it would go to the D block where it is not belonging. So we will not discuss about the chemistry of actinoid, neither the lanthanoid here, because it's very complicated. You will see them in the D and F block elements in the 10th class. For now, let us only focus on the given 2 points. And one more point, that your actinoids are radioactive. So all of the actinoids are radioactive in nature. Lastly, if you see the lanthanoid, you have a uranium. After uranium, the elements are called as trans-uranium elements. So these are some general points. There is no logic behind it. They are just facts. Try to memorize them, right? So 5 facts are related to this F block elements. It's very important to memorize these 5. One-liner questions are always asked from this part of, I would say, this kind of theories. Okay. Now here is a question for you. So this may take time, but I am giving you some time to solve it. The element Z is equals to 117 and 120. They are not discovered yet. But if they are discovered, then which group you should place them, and what would be the electronic configuration of those two, that is 117 and 120 atomic number elements. So your time starts now. Okay, your time is up. Let us look at the answer. So if you write the configuration of both of this, now this would be a long task for you, but you should try to attempt this type of questions. Maybe the questions may not be asked in the competitive exams, but they can be asked in the board exam, first of all. Second, I would say benefit of solving this type of question is that you would be able to write the configuration of elements quickly. So that is very important. And me too have faced this kind of problem related to the configuration part, because it is difficult to do so. Then what is the key thing to solve this problem? I have used the same thing. Try to write the configuration of each and every element. Means if you are near your exams, then don't write. But if you are preparing for it, try to write the electronic configuration whenever you see a related question like this. So this will help you in every exam. It's very, very important. Okay. So suppose we are taking the Z is equals to 117. If you write the electronic configuration, the valence electronic configuration would look like this: 5f14, 6d10, 7s2 and 7p5. Since your D is not containing 0 or 1 electron, it is greater than 0 or 1, therefore it will not belong to the F block. That thing is for sure. Similarly, your outermost electrons are lying in the P block. Okay, you can see that the electrons in the P subshell. If I ask you, what are they? Are they halogens? Are they chalcogens? Are they noble gases? What would be your answer? If you know the electronic configuration, say, then what would be your answer? What are they? Are they halogens, chalcogens or noble gas? So I am leaving this question to you. Yes, that would be halogens. Very good. Now, what about the Z is equals to 120? Try to write the electronic configuration. You will get this. So the last element is 118. If you look at the periodic table, remember the last element is 118 and it is at the bottom corner, at the last column. So that belongs to the noble gas. After that 118 we have 19 and 20. So that would obviously belong to the alkaline earth metal. Just try to analyze the situation. I guess that would make also more sense to you. Okay. So I guess I am putting my point properly. So just try to summarize that. Okay, yeah. So your 118th element is on the last bottom corner, rightmost bottom corner, which belongs to the noble gas. So if it is there, after that we have 119 and 120. So that must be belonging to the alkaline earth metal, which is having 2 electrons in the outermost subshell. And we know up till 7th period we have the 118, therefore it will belong to the 8th period, and hence we have given it as 8s2. Now we will move to a very known topic for all of you, which is metals, non-metals and metalloids. But still I have put this topic for you. First of all, to get an idea what you know till now, and second, what is their positioning in the periodic table. So this can be understood with the help of color coding that is given in the NCERT. So it is very well defined there. So at the bottom where it is written figure 3.3, you will notice that metals are being denoted by 4 distinctive color, right? Which is sky blue, then we have a pink color, and then 2 more colors are there. Okay, at the bottom you can see it. Then non-metals are denoted with a green color and 1 more color, and the metalloids are denoted with a orange color. Now keeping this color code in your mind, get back to the periodic representation. You can see the S block element, the whole S block element has been painted blue. That means they are metals. Similarly, in the middle part, D block, the color that is used for these elements, they are also inside the metals bracket. Okay. And the lanthanoid and the actinoid color codes are also in the metal color code. I guess you are getting this point. Then for the non-metals, we have the green color. You can see it here. It is on the P block. They are all green color. Plus this 18th group whole is being shown in the non-metal. Lastly, your metalloids are in between the where? In between your metals and non-metals. So this is very important point to remember. So if you move from left to right, you have the S block, metals, then you have the D block, metals, then you have the P block in which some part are metals and non-metals, and between those you can see a zigzag line going like this: silicon, germanium, germanium, then arsenic, arsenic, then down one is antimony, then tellurium, then polonium, then lastly your astatine, right? So you can see a zigzag line which is representing the elements of metalloids. I guess this part is clear to you, that where is the positioning. Now we can summarize this positioning in our tabular form. So this is your tabular form. On the left part of the periodic table we have the metals, on the right part we have the non-metals. Now rest of the points are quite familiar to you, so I will not go through them. If you want, you can take a screenshot and read it after the class, but they are mostly known to you. So it is important to remember the name of the metalloid. So this is an important part. You must have heard the term metalloid. There is no issue in that. But you only know about few elements that are metalloids, like your silicon or germanium. But there are 1, 2, 3, 4, 5 names, which include silicon, germanium, arsenic, antimony, tellurium. Now it is important to remember all these names. All these 5 names, which includes silicon, germanium, arsenic, antimony, and tellurium. Now, your metalloids, as the name suggests, they have property in mediate between the metals and non-metals. And this can be picturized here in the periodic table, which is shown with the help of a zigzag line. Okay, so this is your zigzag line. I guess this metalloid part is clear to you, so there is not much to talk about. So boron is a non-metal. It is not a metalloid. Okay, boron is a non-metal. So this selenium is also a non-metal. So here is a question for you. Consider the atomic number and position in the periodic table. Arrange the following elements in the increasing order of metallic character. So you have some time to solve this question. Your time starts now. So what would be the order of the metallic character? The answer would be phosphorus, silicon, beryllium, magnesium, and sodium. Okay. So the least one is phosphorus and the most one is sodium. Now why are we saying it so? Because if you see, then you know that on moving from left to right, the metallic character decreases. So sodium is in the first line, okay, in the first line. So it is the most metallic one. Then comes the magnesium. Okay, so this is the order. Now sodium, magnesium. Now if you look at the beryllium, then first of all, hydrogen, helium, lithium, and beryllium. It is falling in a period which is above the sodium. And you know that as you move down, the metallic character increases. And since beryllium is above the sodium and magnesium period, it must be a less, I would say it must having a less metallic character than these two, because it is falling in a period where it is above the sodium and magnesium. And second thing, it is lying on the right side corner. We have seen the classification right now. Then comes the silicon and then comes the phosphorus. I guess it is clear to you. So what are the key points that we have remembered? So if I try to summarize it in the 3.61 to 3.64. So this is the general electronic configuration that we have seen till now for different block elements. Then hydrogen and helium are exception to this categorization because of their distinction in the electronic configuration and the property. Third point is metallic character decreases from left to right and it increases from top to bottom. After that, S block elements, all of them form ionic compound except the lithium and beryllium. Then one more important point, that are S block and P block elements are together called as representative elements. And lastly, the D block elements which have an incomplete subshell in the ionic or neutral form are called transition elements. And if you do not remember the definition, no problem. Only remember one thing, that all the D block elements are transition elements except zinc, cadmium and mercury. Now what I would do, I would write all of the exceptions at one slide. So what were the exceptions? So before that, this is the table difference between metals and non-metals. So I have given this summary so that you can make a notes out of it. What about the metalloids? So they have a property in between the metals and non-metals, and this can be seen in the pictorial representation. So these are the exceptions that we have seen today. Hydrogen and helium, they do not fit according to their electronic configuration, so they are exceptions. Second thing, zinc, cadmium and mercury are the only D block elements that are not transition elements. Third thing, lithium and beryllium are the only S block element that form covalent compound. And lastly, your S block elements and P block elements are together called representative elements. Now one more name is given to them. I have told you about that, so I am leaving it to you. So this was all for today's class. I hope you enjoyed the lecture. Thank you.